The human body is amazing in the way that it blends functional anatomy, physiology, and physics together to produce human movement. We can better understand how movement occurs by defining some key terms and looking at the muscles and joints of the arm as they function. When focusing on the upper arm, it's easy to notice that the biceps brachii is the muscle which produces flexion at the elbow. The term biceps brachii is Latin meaning two-headed muscle of the arm in reference to the fact that the muscle consists of two bundles of muscle, each with its own origin, sharing a common insertion point near the elbow joint. The biceps is a triarticulate in nature, meaning that it works across three joints. To understand how the muscles work with the skeleton in providing motion, we must look at the basic mechanics of movement. The main framework of the body is covered by muscle, whose function is to permit movement. We know that to move or lift a load against another force, it's easier to use levers, and it's this principle which the musculoskeletal system adopts and which we must examine. The component parts that are used in a lever are as follows: the lever itself, which is nearly always the bone in the body; the fulcrum, which is the pivot point of the lever, which is usually the joint; the muscle force, which is the force that draws the opposite ends of the muscles together; the resistive force, which is the force generated by a factor external to the body that acts against muscle force; and lastly, the torque, which is the degree to which a force tends to rotate an object about a specific fulcrum. There are different types of levers dependent upon what the position of the fulcrum, effort, and resistive force are. A third-class lever uses muscle force and resistive force to act on the same side of the fulcrum. The muscle force acts through the lever shorter than that through which the resistive force acts. An example would be flexion of the arm. Flexion decreases the angle of the joint and brings the articulating bones closer. The weight of the arm or something held in the hand is the resistance. The elbow joint is the fulcrum, and the contraction of the biceps brachii muscle is the effort. Most of the limbs of the body are articulated by third-class levers. Every muscle has an origin and an insertion. For a specific muscle in its primary movement, the origin of a muscle is the point at which the muscle attaches with a tendon to the stationary bone. The opposite end, where the muscle attaches to a second bone, is the insertion. This definition means that there's a functional aspect to the definition of a muscle's origin and insertion. Both origin and insertion are important for understanding the function of a muscle. The best way to decipher which is the insertion and which is the origin is to reason through the muscle and its movement. When you flex a muscle, the insertion moves towards the origin. So the origin of your bicep is near your shoulder, and the insertion is on the top of your forearm. Proximally, the short head of the biceps attaches to or originates from the coracoid process of the scapula. The tendon of the long head passes along the interturbicular groove of the humerus into the joint capsule at the head of the humerus and attaches to the scapula at the supraglenoid tubercle. Distally, the biceps attaches to the radial tuberosity. Because the ulnar and radial bones can rotate about each other, the biceps can powerfully supinate the forearm. Now that you know a little more about the biceps brachii and how it functions, you can use those key concepts to help you better understand human movement in the rest of the body.